The second class, broken authentication and session management, is happens when attackers can effectively circumvent authentication or steal other users' sessions or somehow influence the content of those sessions. Okay, so broken authentication normally results in circumvention of certain controls, authentication controls in the web application. For example, an extreme example can be like in mobile application or a web application, if there are some actions that should be in logical order, starting from the login screen that demands user authentication, yeah, and there is no control over the sequence of the steps of web application workflow, right? And the user could just instead of putting either login name and password into the first screen, issue the second screen or the third screen of web application workflow, right? Just referring by URLs, for example. That could be an example. Okay, so imagine that as you just, for example, have an illegitimate account in the web application, and you go to a domain, to the root of that domain, and you are presented with a login form. And when you log in, you see that you are redirected to some other parts of the web application. Yeah, so you just can copy those URLs and try to access them in a different browser. And if you see that you can directly go there without any proper authentication, this is the sign of the authentication is really broken. Okay, the session management is broken when you could, for example, just hijack the session of a legitimate user. So that happens sometimes when there is no proper session control. For example, there is no a unique token that is reissued every time the session is established, right? So you could just reuse a token that is left from the previous session of another user, or you can just get the token from sniffing the network traffic, or you could just guess the token. Okay, that happens. Yeah, that happens a lot. So you just can guess the value of the token and then craft the requests in a way that the web application just thinks that you are that user and behaves accordingly. Cross-site scripting is a class 2, first of all, because it's really popular. It's most probably prevalent in the wild. And second is that there are 3 types of XSS. Okay, so XSS vulnerabilities can be either reflected or stored or DOM based. So XSS is basically just making the user that is the target in this attack execute your code, the code that is deliberately provided by the attacker in their browser, in the context of their current browser session. So imagine that as you are just somehow triggering the code execution in the browser screen. Yeah, so JavaScript, for example, is run within the current legitimate session, and really bad things can happen. So, for example, session hijacking is one of the possible results. Yeah, you just steal the cookie somehow. You throw it at the server you control, and it's registered in that's web server logs. So that can be done in 3 different ways. So first of all, you can just send a link, or just in some other way cause the user to point the browser on the URL you provided. I don't know, maybe even just sending an email and putting the image into that email, image tag, HTML image tag that is referring to to the URL you control, yeah, or in some other way. So in this case, XSS will be reflected. So you do something, and then it's reflected in the browser of the user. So what happens then is just run, and only the people who are explicitly targeted by that attack will be harmed. Okay, if the user chooses to pass your message, pass that URL or email to other users, they will be harmed as well. But that's more or less limited to those people you aim the attack at. What does it mean when XSS is stored? This is a result of your ability to store that script code somewhere on the backend or in the middle of the backend and the web application. Yeah, the main idea is to put it somewhere where it will be then read and used to generate pages the web application presents to its users. Okay, so one of the examples can be, for example, there is a message board, and you can leave messages on it, and you can put JavaScript code in them, and it's not filtered by the web application, and is run on every of other visitors browser. Yeah, once they visit that page, you have just modified, yeah, they will be executing that JavaScript. So this is much more broad in possible number of victims, but the harm is the same. Yeah, so you can just manipulate the session and redirect the user somewhere you control, and so on. What is DOM-based XSS? It's there is this DOM model, yeah, in the browser. So every website is basically a class, a model that has different parameters, and they have different values. So DOM is slightly more tricky, yeah, and the trick is that you put code into different DOM elements, like, I don't know, location, yeah, of the page, for example, and that location is then used as the value for generating a piece of code on the page, yeah, and in this trickier manner you still smuggle the code to the web page somehow. So that's more that's less easy, I would say, to exploit than traditional XSS stored and reflected ones, but still that's possible, and you should be aware that it is not a rocket science. So the fourth category, of course, is insecure direct object reference. So what it is, I would say it's not a clever way to name or refer to sensitive data in the web application, and as a result, that operation, that reference to objects, yeah, of sensitive nature, can be observed by users, and they can infer that all right, I can get my data by these URLs, yeah, that are basically just numbers in the location bar. Can I increment those numbers in order to maybe get access to some other objects that do not belong to me? Okay, so that's what it is, and that's quite sad that happens too much, yeah, and even some security products were found prone to this kind of vulnerability. So yeah, that's quite silly. This can be easily avoided, but there is a lot of legacy code out there, and once you can predict these paths, these URLs or other kinds of references to sensitive data, and you just start like scripting massive access to those new guest names, yeah, and downloading everything that you find by these URLs, you are basically exploiting that insecure direct object reference, and yeah, that happens. Many data leaks are caused by that. one of really sad consequence of that can be search engines indexing those direct object references. Okay, so once it's in the Google cache, it's not easy to remove it from there. So even if you just close that insecurity, provide some access control that limits access to those directly referenced objects, it's still in the cache already, and you will have to deal with Google bureaucracy in order to remove that from the cache. The fifth category is security misconfiguration. We briefly described that in the previous slide. So that's any kind of operational mistakes that were created, that were introduced into the configuration of the web application and the underlying platform and infrastructure during the development and deployment. So falling back to null ciphers in SSL, maybe one example, or leaving default credentials in Tomcat is another example. The sixth category, sensitive data exposure. So this can be exploited in many different ways, starting from too descriptive error messages that disclose absolute paths to application installation or configuration files, to, for example, just leaking some data from memory, okay, just as Heartbleed, for example. You may remember this really nasty OpenSSL vulnerability that caused sensitive data exposure in a really easily exploitable manner. Okay, so that's just putting the data in the wrong place, or allowing too much access by default, or just not regulating that access according to the need to know. So that's what sensitive data exposure basically is. A seventh category, missing function level control. That's quite tricky, I would say. So let me explain that by an example. So let's say you have different roles in a web application. So there is an admin and there are users, just the users, business users of the web app. And let's say the user once was given that access of an admin, and he or she observed that there are different functions that are available on the web application page once you are logged in as administrator, and are unavailable to all the rest, all the other users. And he notices that, and then when the administrative session ends, just repeats referring to the same parts of web application without administrator authorization, but just because he or she knows the paths to those functions, to those tools, they are allowed access to them and effectively using them. So this is what missing function level control. This means that if you successfully limit the visibility of functionality or limit the access to functionality physically in the browser, on the client side, you still have to check that authorization, that permission to run the function on the server side. Okay, just limiting the access is not enough, because if the user knows it's there, reads the documentation and retrieves the knowledge that it's there, or just observes that it's there on the administration screen and then knows those API calls and runs them manually on a scripted manner, the application will fail. Okay, so this authorization model will be totally ineffective. And the eighth category, cross-site request forgery, that's quite I would say that's an edge case. Depending on the nature of the web application and the current state of the session, it's quite questionable whether it's posing any risk to the web application or the user. So imagine the situation when you have a valid session, when the user has the valid session, and you somehow trigger the browser to issue a request somewhere. Okay, so they are authenticated and you get them to run a request. That means that that request will be processed in their context. So for example, if it's a payment application and you somehow are able to manipulate them to issue a request that transfers money to your account from their account. So it's a cross-site request forgery, but it's too prevalent in the wild, and it sometimes is just explicitly removed from the scope of bug bounty programs, for example, when it's not authenticated or authenticated as non-sensitive users. So that's an edge case, apparently. But it still can be nasty. So if you are an admin and you are tricked to issue a request to some administrative function that just enables elevated permissions to some other user, that belongs to attacker, you are probably in a big trouble. Category number 9, components with known vulnerabilities. What it is just supply chain corruption, I would say. Okay, so a lot of reused code, a lot of frameworks. Frameworks always are constantly hacked by different researchers that are trying to find more and more vulnerabilities in them. And as long as you use the frameworks that are prone to known vulnerabilities, your application is vulnerable as well. For example, there are limitations, of course, but for example, you use a function that has vulnerability in it, and you get vulnerable as well. You don't use that vulnerable function, but still use that potentially vulnerable framework, you are not vulnerable. Okay, so once you find that the web application you are trying to hack into uses a vulnerable framework, do not hurry and do not start writing that finding into the report, because the vulnerability will be there only in the case when your target web app uses that specific vulnerable function. Pay attention to that. It's not a vulnerability by itself. You have to investigate further and understand whether the vulnerability is actually in there, because there are different classes and functions in each framework, and only some of them, only really limited subset of them, can be vulnerable. And finally, the 10th category is unvalidated redirects and forwards. Sometimes web applications, normally, I would say, so nowadays most web applications normally redirect you as a user to different parts of it, and even outside the applications to some other web apps that they pass over the control over your further interaction with the business logic they implement, jointly. So if you somehow can manipulate the input that the web applications use to form those forward and redirect URLs, that's the unvalidated redirected and redirects and forwards vulnerability by definition. So if you can influence where you will be redirected for further processing, you successfully exploit that. What can be possible harm of that? So let's say a web app creates a package, some kind of JSON packet, for example, so the structure that contains sensitive data, and then it redirects you to somewhere where that data should be processed, in some specific way, and then presented back to you. And that in that sequence you are not supposed to know the exact data. Okay, so you just like are presented with some encrypted or some how protected packet, and you are like supposed to go with that somewhere, and that component where you come and present that packet will process the packet and give you out the result. So let's say you don't have direct access to that data, but if you can redirect, if you can influence this redirect functionality and cause the redirect to the server you control, you can significantly extend your potential of attacking that functionality. Okay, so if you can control some part of it, you can perform, I don't know, some cryptographic chosen ciphertext attacks and so on. So that's quite a complicated approach already, but yeah, causing trouble and making things less simple to web developers is the right way of trying to compromise their products.